Okay, so my name is Brad Hedlund. I'm with VMware, with the Networking and Security Business Unit. And we're kind of the pirate ship at VMware right now. I'm not out to sell more ESX or more vCloud Director. What we're working on is a standalone networking product for network virtualization for software-defined networking that works in any data center, with any hypervisor, any cloud management platform, any physical network, on top of any servers. By the way, somebody did fix that. I misspelled virtualization, so I wanted to make sure that wasn't the fault of the Geek Day staff. So I looked at my slides list and I'm like, I didn't just do that. I didn't just not know how to spell virtualization, but I did. So anyways, what slide are we on here? This one still? Okay, that's my next slide. So I'm not going to try to define SDN and things like that. What I want to take a look at is take a step back and look at what are the problems that we're trying to solve and how are we going to try to solve them. If we take a look at what's happening in the network, if we take a look at the physical switch like this, we have things like the distributed forwarding state. This is moving packets from one point to another. Routing protocols, OSPF, BGP, ISIS, these things work really well. Networking has done a great job at the data plane, at the distributing state of forwarding packets from one point to the other. This is something that does not need to be reinvented. Layer 2 tables, layer 3 tables, any link fails anywhere in the network, we know how to get from one point to another. What's really hard, and where networking hasn't kept pace, is this manual configuration state. These are the things that I need to provision in the network to stand up a service, to match what's happening in the compute. VMware introduced ESX in 2001, which brought programmability, rapid deployment, mobility to the compute environment, but the network didn't change. So everything you see there in blue there are the things that have to be provisioned for this now suddenly fluid and mobile compute environment. And using CLIs, this is basically human distributed state management. CLIs, I go from one switch to another switch to another switch, set up the VLANs, set up the ACLs. There's no routing protocol for ACLs. There's no routing protocol for NAT, VLANs. This is all done manually with CLIs. So I think this is the sweet spot for the clicker right here. So we talk a lot about OpenFlow and SDN, and OpenFlow is about separating the control plane and the data plane. And I don't want to take a look at it that way. I want to take a look at separating network policy from packet forwarding. Packet forwarding works really well. So the obvious approach that some people are taking is, hey, let's throw an OpenFlow controller out there, and let's separate the control plane and data plane and completely disrupt the whole thing. Change the way distributed forwarding works. Change the way configuration state works, which really amounts to SDN being better network device management. So we're not really taking this approach. We're not going to throw an OpenFlow controller out there, and we're not going to touch the physical network. It's kind of like if you have a bad knee, right? I've got a bad knee, and I go to the doctor and say, you know what, I'm having a slow time walking here. I've got a bad knee. I'm not able to keep up with the rest of my friends. What should I do? One approach would be, hey, let's get a whole new prosthetic leg, right? Just disrupt the whole thing, put on a new prosthetic leg, it's got a great new knee. You'll have to learn how to walk again, but that's okay. You'll get there and you'll catch up to speed. What we want to do is focus on what the real problem is. The problem is this manual configuration distributed state that we need to program in the network for this mobile compute environment. Something that's not hardware dependent either. That's non-disruptive. Oh, I'm looking at the wrong set here. Yeah, so what we want to do is take all of that red and the blue. So the red is that distributed forwarding state that works really well. And let's introduce a network virtualization layer, an abstraction layer, very similar to how ESX provided an abstraction and virtualization layer for servers. And we'll introduce a distributed controller. This is something that's very hard to do, a scale-out distributed control plane that takes all of that manual configuration state and now virtualizes it and presents it with an API and a single point of management. So we take all of that manual configuration state and we put it up into the virtual network. We virtualize it. We create an abstraction layer. We abstract more simplified devices, simplified logical switches, simplified logical routers, simplified logical instances of firewalls, load balancers. And we present that in an API, which lives in a software layer. And where a particular virtual network spans from one server to the next, we'll have that distributed control cluster create tunnels dynamically between the hypervisors to implement that. We can also work with gateways, too. If there's a virtual machine that needs to talk to a physical machine that's non-virtualized, let's plug in a gateway through NSX or through one of our partners to provide that seamless bridging between virtual and physical. So let's take a look at network virtualization. What is? I think there's a lot of similarities between server virtualization and network virtualization. They both provide abstractions, simplified logical devices. It used to be when you ran an application on a server, you had to figure out what the requirements of the application were, how many NICs does it need, what kind of hard drives, what kind of CPU, size the RAM properly. That took a long time to do, and each server had a custom build for that application. Network virtualization or server virtualization abstracted all of those devices away, like a virtual CPU, virtual RAM, virtual disk, virtual vNICs, and you present that as a logical x86 environment for the virtual machine to consume. And it's non-disruptive. That application still sees an x86 environment, and it works on top of any modern x86 hardware. We do the exact same thing with network virtualization. We use that vSwitch layer, a programmable layer 2 through layer 4 data plane with that distributed cluster, controller cluster, to abstract more simplified logical networking devices. A logical switch, a logical router, so on and so forth, a logical port. And then now we can construct, just like I can take any combination of vCPU, vRAM, vDisk to make a virtual machine, I can now take any combination of logical switch, logical router, logical port, logical firewall, logical load balancer, and create the virtual network. And it's non-disruptive. The network, the workload, still sees layer 2 through layer 7 services. And what we require underneath that is IP transport. We assume that there's just a IP fabric there, a modern IP fabric, to write on top of that. One of the things that enables virtualization, especially with server virtualization, is encapsulation, decoupling. A virtual machine, as we know, is like a VMDK file. All of that vNICs, vRAM, vCPU is described in a VMDK file. It's encapsulated in a file, and it's placed on a SAN somewhere. Encapsulation is a fundamentally enabling concept for virtualization. Same thing with the network. We encapsulate that virtual network into IP tunnels on the physical network fabric, just like a VMDK file is encapsulated in a file and put on the SAN. So at VMware, we're working on VMware NSX, and this is something that is going to be a new product. It's going to combine the best of the Nicira acquisition that VMware made. What do we get from Nicira? We got the distributed controller cluster, the layer 2 to layer 4 programmable vSwitch. Those two things together make that common network virtualization hypervisor. We also have the VMware vCNS portfolio, which I'm sure you're aware of, where we have the edge appliances, vCNS Edge, with load balancers, firewall, and security. So it was a great match. There wasn't a lot of overlap between what VMware had and what Nicira brought to the table. So we're going to bring those two things together. We're going to provide a platform called VMware NSX. And again, I said I'm not here to sell more ESX and more vCloud. It's going to work on any cloud management platform through standard APIs. OpenStack, we'll work with OpenStack. We already are working with OpenStack with Nicira. If it's a VMware vCloud, and if you want a tightly integrated vertical stack with easy buttons and handholding, we can do that too. And we're not trying to boil the ocean here. We're not saying we're going to do it all, layer the whole stack, and everybody else can go home. We've got the whole thing here. We want to provide the platform that integrates well with partners. So what you see here on the right-hand side, layer 4 through layer 7 appliances, we can work with folks on those hardware appliance vendors there, be it F5, Palo Alto, whoever. Don't quote me on that, but all the possibility. We'd love to work with MBrain to bring together through those standard interfaces, whether it's the same common tunneling protocols, common configuration APIs, and then on the other side, we can work with physical switch vendors as well to provide gateways from virtual to physical. That could be a Cisco switch over there that's providing a bridge between a physical port and a virtual port. No reason why it can't be. And of course, we have the edge gateways too. VMware vShield Edge, we could provide things like IP routing, NAT, firewall, load balancer, if what we have is good enough, or if you need more capabilities than what we have. Hopefully one of our partners brings that to the table as well. So I think I'm going to wrap it up there. I'll hang around for more questions. I just wanted to give you a quick taste. We won't have anything to show right now, but hopefully at the next Geek Day, we'll be in the lab with VMware NSX running, and we'll have a lot more to tell you then. Thanks for your time.